What's up, Math 8? Thanks for tuning in. This is Miss Mullins for another episode of Math with Mullins. Today we're going to talk about our Chapter 4 Test Review Part 1. So this is going to include all of our lessons 4.1 through 4.6, mainly focusing on transformations and similar figures. The first question on our review sheet says the vertices of a triangle are A, 8, negative 24, B, 8, negative 8, and C, 8, negative 18, negative 9. If the triangle is dilated by the scale factor of 1/3, what are the new coordinates of C prime? Looking at C, we have 18, negative 9. And when we have a scale factor of 1/3, that just means to divide by 3. So we're going to do 18 times 3 divided by 3 and negative 9 divided by 3. That's going to give us 6 and negative 3. So my answer should be 6, negative 3, option C. The next one, the polygons are similar, solve for x, be sure to show your work. What we need to do here is match our small shape with our big shape. So I started with the one that was given. 6 matches with 9. So on my small shape, x will match with 18. Notice how I compared small to big each time. Then I can cross multiply. 9 times x is equal to 6 times 18. 9 times x is 9x, and 6 times 18 is 108. Finally, I divide both sides by 9. X is equal to 12, so that is option C. Number 16, these are also similar figures. You just have to be very careful. Here I started with the bigger shape and compared it to the smaller shape. So 8 matches with 4. In the same way, 20 matches with x. Some of you notice that 8 and 4 have a relationship, so you've probably already found your answer without having to do the proportion. But in case you didn't, go ahead and cross multiply. 8 times x is equal to 4 times 20. 8 times x is 8x. 4 times 20 is 80. Dividing both sides by 8, x is equal to 10. Some of you notice that 8 is exactly twice the size of 4, so 20 would be twice the size of x. So that means x has to be 10. Draw the image after each transformation and use your picture to choose the correct vertices. So what we're going to do is we're going to translate each of these 2 units to the right and 5 units up. I'm going to start with letter J. 1, 2, up 1, 2, 3, 4, 5. J prime is now at 0, 3. So what I go ahead and do is I look for my J prime, and the only option that has 0, 3 is option A, which just means I want to double check, make sure these aren't it. H, I go over 1, 2, up 1, 2, 3, 4, 5. H prime is at negative 2, positive 2. So far, A is still looking like it's it. L prime to the right 2, up 1, 2, 3, 4, 5. That is at negative 3, positive 1. And then K prime to the right 2, up 1, 2, 3, 4, 5, negative 1, 0, which means A is my correct answer. If you want to, you can go ahead and connect all these points together. It still should make that same figure. Now let's see what happens for this one when we reflect over the x-axis. One thing you want to keep in mind is I would maybe draw your line over the line of reflection, which is the x-axis here. In order to reflect point J, I'm just going to count how many steps J is from the x-axis. It's only 1, so I go 1 step in the opposite direction. J prime is at 3, negative 1. H prime would be 1, 2, 3, 4 steps away, so 1, 2, 3, 4 steps away on the other side. This is at 1, negative 4. And G prime is 1, 2 steps away, so 1, 2 steps away on the other side. G prime is at 4, negative 2. 4, negative 2, 1, negative 4, and 3, negative 1 are letter A. If you want to, you can also connect your points, but it should still show that reflection over the x-axis. Tell whether the 2 figures are congruent and explain your reasoning. So right here, it looks like they're congruent, but we want to know why. So yes, they are congruent because all sides are equal, and not all sides, but corresponding sides, and all corresponding angles. Are equal. Okay. 21, tell whether the two sum figures are similar, yes or no. What I look for first is, do they have proportional sides? And it looks like yes. So I'm going to say yes. Their corresponding sides are proportional and their corresponding angles excuse me, are equal. Okay. Last little bit, draw the image after the transformation, list the ordered pairs of the vertices in the new image. Remember, if we are trying to do 180 degrees about the origin, all we're doing is we are flipping around and creating a 180 degree angle. So here would be y prime. Y prime is now going to be at 2, -1. Notice that the previous point y was at -2, +1. So all you're going to do is take your previous points and just make them their opposites. So for instance, letter x is up here at -4, 6. So x prime would be +4, -6 down here. Okay. W prime the same way. W is currently at -5, 6, so W prime would be +5, -6. Here's +5, down here is -6, W prime. And then the last one, V was at -3, 1, so just change everything to its opposite, +3, -1. Here would be V prime. As you connect your points, you should notice it's the same shape, it's just been rotated 180 degrees around the origin. Dilating with the scale factor of 3, it would be helpful if you wrote your original points first. So T, V, W, and X. T right now is at -3, 2. V is at 3, 2. W is at 3, -2. And X is -3, -2. Since we're dilating with the scale factor of 3, I'm going to multiply each one of these numbers by 3. So T prime would be -9, 6. V prime would be 9, 6. W prime would be 9, -6. And X prime would be -9, -6. Let's go ahead and plot those points and label them. I'm going to start with X prime. -9, -6 went off the border just a little bit. In fact, most of these will. That's okay. T prime, -9, +6. W prime, 9, -6. And V prime, 9, +6. Okay, when you're done and you're connecting your points, you should notice that your rectangle is 3 times the size. We went too far for V. Here we go. Ta-da! The following polygons are congruent. Answer the questions below. What is the side length of LM? Here's LM, and LM corresponds with DC, so the side length of LM is 7. Side MN is congruent to side NP. What is the side length of MN? Well, NP is also congruent to EF, which means this is 18, which means MN is also 18. What is the perimeter now of CDEFG? CDEFG is this shape over here. I know that this one would be 18 and this is 14. So what we're going to do is we're going to add all of our numbers together. 18 plus 18 plus 7 plus 14 plus 11. 18 and 18 is 36. 36 plus 7 is 43. 43 plus 14 is 57. And 57 plus 11 is 68. So 68 should be your perimeter of CDEFG. That's going to conclude our review on Chapter 4, Part 1. Thanks for tuning in. Hopefully you do great.